Hello and welcome to the third part of my Unity Bullet Hell C# tutorial. Today we're going to do a bit of housekeeping, prevent some problems with infinitely spawning objects, and make our shooting a little bit more satisfying. And then the main focus will be introducing some element of parallax scrolling. And then we can also experiment with different forms of parallax scrolling for other different kinds of games. So at the moment what we have for our game is from the last tutorial, where you can move around, we can shoot at the enemies, and whenever the enemies take a certain amount of damage, we're able to destroy those enemies. And whenever we get hit by something, then we die. So one of the things that we're going to want to do here to make our combat a little more satisfying is that whenever we shoot the enemies with our projectile, at the moment it just sort of goes through the player object, the enemy object rather. So our player projectiles go through the enemy object, which means it doesn't really look like they're hitting the enemy. So let's very quickly go to our enemy script and open this up in Visual Studio, so that whenever we check if the enemy's been hit by a projectile, then we destroy the projectile. Here's the code here for when on trigger enter, for whenever something collides with the enemy, we take 1 damage for our current health going down. So additionally, we're going to go ahead and destroy the object that just hit us, which is the player projectile. We can get the player projectile from this argument that's being fed into the on trigger enter 2D. This is a collider 2D other, and this other is going to be a variable that represents the object that collided with us. In this case, it's the player projectile. So we can very easily just do destroy, and then we can destroy other. Now, other at the moment is the collider 2D script that's attached to the object that we're colliding with. So we're going to access the game object of this particular script. So the game object that script is attached to, and then we can destroy that, which means now whenever we I just saved the script there, so it's now refreshing the project. And now whenever I run the game and I shoot the enemies, hopefully my projectiles will sort of disappear as they hit into the enemy. Boom, 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 and then they explode. It's still not quite just very particularly satisfying though, because there's still not really the indication that I would like to see from getting hit. We would actually, probably what we want to do is create a little explosion, like a little explosion sprite every time we hit something. So I'm going to very quickly go ahead and create a new sprite in Piscal. Let's see, I was resized 32 to 32. All right, let's create a little explosion. It's going to look a bit similar actually to our projectile. So how can we make this look a bit different? We'll make it a bit more rounded. Whatever. The point again is not to make something that's good. This is just to show you how you would implement something. Maybe it should just be a big gray cloud. All right. So there's some sort of explosion. Doesn't really matter what it looks like for the purposes of just implementing the code. So I'm going to go ahead and export and download this image of the explosion. Oh, by the way, at the moment I have this tiling because I went to settings and tile mode and turned on the tile mode. And that's because of the parallax scrolling thing I'm going to show you after this. If you're wondering why it looked so weird. So now we've got our image. I'm going to drag this image in. So don't forget, because it's pixel art, we're going to turn off compression and filtering. So our crisp pixel art looks lovely. We're going to go ahead and create a new object. This is the object that's going to appear every time we hit something, and we'll call this like explosion. Oh, I forgot to add the sprite, so let's go ahead and add the sprite renderer. Keep in mind, guys, that the sprite renderer is for our actual 2D objects in the scene, and our UI image component is what we want to use for our UI. Sometimes it can get confusing between those two. So now we can go ahead and add the sprite of our explosion. Let's make that explosion a little bigger in size, maybe like a 2:2. Oh, let's try making it big to start with, and then we can change. So I'm going to zero out all of these coordinates before I turn this explosion image into a new prefab. Now that I've got the explosion prefab, I can delete the version of it in the scene, because we're only going to want to spawn it in. We don't want any explosions when the game starts. Alright, so now we've got our explosion. We just need code that spawns it in whenever we take a damage. Just like we have the projectile as a game object variable prefab, we're going to create a new game object, which will be, hit explosion, let's call it. But you could call this whatever you want, whatever you think makes sense. Oops. And so now we're going to go ahead and instantiate that object, just like we do with the projectile. So look, here's the code here for instantiating our projectile. So I'm going to copy that code and put it in here when we take damage. This time we're not spawning in the projectile. We've got to change this to our explosion. And look, we can even autofill our own variable names now that we've already established them. So then this will autofill to hit explosion. Yet we want it to appear where we are. We're going to set it to the identity. It's important that we spawn in the explosion before we destroy ourselves, because otherwise I have a feeling that it's going to complain, because we're going to destroy ourselves and then try and spawn something where we are, and then it'll be like, that doesn't make any sense. We're already dead. Anyway, so we've instantiated the explosion. Let's go ahead and see what happens when we run the game. Well, actually, before we run the game, I'm just going to preemptively fix my mistake, which is the classic thing that I always do, which is try and run the game without setting up my variables correctly. I've got to set my hit explosion variable to the explosion prefab, so it knows what to spawn in. Alright, so I can move around and shoot at things. I'm going to try shooting at these enemies, and you can see these explosions are appearing where I hit them, which is kind of cool. But they're just sort of permanent explosions. Maybe there's some sort of physics thing you could justify that with. The debris will never go away in space. But we don't want that. We want our explosions to go away, so we're just going to add a simple timer script to them so that they automatically just delete themselves after a certain amount of time. Let's just call this explosion. Create a new script to attach to the explosion prefab. And hopefully this sort of timer stuff should be familiar to you by now. If not, have a wee look and see, how we're doing timers in general. But, we're really just using the classic two variables, right? So we've got one variable, which is our timer, which is what we're going to use to keep track of how much time has taken place. And the other variable, which is going to also be a float, which is going to be the max time, which is going to be, it's going to check how long has the timer been running for. Okay, has it the same value or greater than this time, and then we're going to do something. And that's kind of like a similar pattern you'll see over and over again with timers. Trying to get things in video games, it's all about timing. It's all about things happening over time as the game runs. So we're going to check, is our timer greater than or equal to time? And if so, we're going to destroy ourselves. So we're just going to do destroy.gameObject. And oh yes, we actually have to make our timer increase over time as well. So we're going to increase it by time.delta time. So as the timer increases, we then check and then destroy ourselves. So hopefully these explosions will go away after a certain amount of time. Let's go ahead and oh, it looks like we didn't successfully add our script. Oh no, there it is. There's a script now. So the timer should be at 0, and the time will say 0.5. Maybe the explosion should last for 0.5 seconds. And we could have an animating explosion, and we'd do a similar thing where we'd maybe just have it animate and then disappear. At the moment, it's just a sprite that appears and disappears. So not particularly fancy. But I think it looks a little bit better than what we had before. To be honest, one of the things I'm noticing is it sort of just really obfuscates what's behind it. So I'm not sure if I'm a big fan of that. Maybe I should check the color of our explosion sprite here. And what I can do is I can go ahead and change the alpha of the color, which means that I'm changing the alpha of this sprite render, which is going to render the explosion as semi-transparent. So now the explosions, I'm not sure if that really fits the pixel art style, having something that's semi-transparent. What if I instead have the explosions being rendered behind the enemies? Maybe that's a good idea. So here in our sprite renderer, we've got an order layer, which at the moment is 0. However, if I change the order layer, so if I compare, I can see the order layer of my enemies also 0 because it's by default. what I can go ahead and do is increase the order layer by 1. Now I can't remember which way it goes. Does it go from 0 to 1 towards the foreground, or does it go from 0 to 1 towards the background? It looks like that didn't change anything, so that means I'm going to go ahead instead and change it to -1, so that it's now a lower value than the enemy's render. So now maybe will the explosion be rendered behind the enemies? Yeah, there you can see now the explosion is sort of rendering behind them. I think that looks a little bit better, so that the explosions don't cover the enemy. It's a pretty hard game at the moment. Okay, cool. So we've got a little bit more of a satisfying explosion that happens whenever we hit the enemy. So we could do the same thing for our player character real quick here. So all we have to do for our player character is copy the same code. So we need to have a hit explosion public variable. Let's go ahead and copy this to our player movement script. And we can also just copy the same code for instantiating the explosion whenever we die as the player. So where's the player? Here it is here. And we could do the same thing with health as well, right? Where we could copy the kind of code that we have for the player taking damage so that the player has health. But for now, let's just have this explosion. And I'm going to go ahead and grab my enemy. No, sorry, grab my player script, which isn't actually a prefab yet. And we're going to drag our explosion into the hit explosion, so it knows what explosion to render when we die. All right, I'm just going to deliberately get blown up. There we go. So we had a little explosion for a player as well. We can make it a different color or something, but I think that's fine for now. The next thing we're going to do is a little bit of housekeeping for objects that, just continue forever. So in one of the previous tutorials, I think last tutorial, we made it so that these enemies that spawn in... Oh, look, I'm looking at this from the opposite direction. Let's change that. These enemies that spawn in, they go ahead and disappear after a while. Like you can see, after they move off the screen after a while, their timer will kick in and eventually they'll disappear. They're not doing it anymore because the game breaks once I'm dead, but hopefully you can see what I mean. Well, we did this last time anyway, basically, where we caused these objects to disappear after they moved off the screen to the left. Can I survive for long enough to show this off? Ooh, it's getting pretty tricky. Maybe not. I'm going to go ahead and change the enemy rate of fire, put it way down just so that I can test this a bit easier. So I'll put this up to 4, which means they're going to only fire every 4 seconds instead of every 1 second. So I can test out my abilities a bit more so that their fire rate is a lot worse now. I quite like our little explosions now. So yeah, as you can see, as they go off the side of the screen here, they should hopefully disappear soon. Otherwise, we haven't done our job. Okay, let's fix this first problem though, which is whenever we die, we get all of these errors. And that's because, and if I double click on this error, maybe it will open up the script. No, it's not. Oh, there we go. One of them did. So basically we've got a player that we're setting by finding an object of the type. However, whenever we die, the player doesn't exist anymore. This transform is no longer a component because we deleted our object. And now it has a problem whenever anytime it references the player. It only references the player once, which is here. It's going to go ahead and use the player position to determine the rotation, I think. Let's see. What do we do? Yes, to determine whether or not we should be firing. Also, whenever we fire our projectile is going to check whether or not there's a player. Let's see, where is it? Our player projectile, whenever it spawns in, or not when it spawns in, actually every update frame, it's going to move towards the direction. Oh no, this is the player projectile. Let me look at the enemy projectile. The enemy projectile is just called enemy. Oh, here it is here. So we set the player to equal to the player when we find it, and then we're just going to set the direction equal to where the player is. And therefore, afterwards, every frame we just move towards that direction. So we're not calculating where the player is every frame. We're just calculating when we spawn in. So actually, what we want to do probably is we're just going to stop spawning projectiles in whenever the player's dead, and that way the error won't happen. And we're also going to stop checking. Where's our enemy? We're also going to have to stop using this player.position. So what I can go ahead and do is just add another if statement for all of this code to exist within. So we don't want to check if the player's position is .x is less than or equal to this if the player's already destroyed. And then this will also help because we're not going to spawn in any more projectiles if this if statement returns false. So to check if the player doesn't exist anymore, what I can actually do is check the value of this player variable and check if it's equal to null. Now, null is a special value for our class variables. So, you know, this game object can be a null variable. This could be a null variable. This transform player could be a null variable. This rigid body could be a null variable. And what a null variable is basically the lack of information. And that's why you always get this. If you don't set up your variables correctly, you get this thing here which says missing reference exception. It doesn't exist. Look, it's been destroyed, but you're trying to access it. However, once we've destroyed it, the value of that variable will now be null, which means that if we check that it's not null, so let's go ahead and add a not null here. So if it's not null, then we can actually use the variable and everything's fine. But if it is null, which is to say if the player has been destroyed, then we'll not do any of this. So hopefully those errors will go away once we die now in this version of the code. So I'm going to deliberately kamikaze here. Boop. We've still got some null reference exceptions, though, that are appearing at the start of our enemy. That's interesting. That's because we're still spawning in enemies, and the enemies are still grabbing a reference to the player. Which means that we have to stop spawning in enemies if there's no player as well. So that's going to be pretty simple. We're just going to grab a version of the player within our spawn manager, just the same way we do within our enemy. So I'm going to go ahead and say, grab this start method and stick it here in our spawn manager as well. We're going to need a player variable. Let's go ahead and grab this. So now we're grabbing the player in our spawn transfer manager, just as always. And we're going to do the same thing. So we're going to stick everything in a big if statement that checks if the player is not equal to null. And that way, if everything is inside this big if statement, then we'll know we won't be spawning any more enemies, and then those enemies won't be asking difficult questions. The enemies will stop looking for the player because the enemies won't be spawning in. So we're just sort of like covering our tracks so that once we die, there will be no more objects, nothing more that's asking where the player is. And we could just keep going with, you know, we could maybe spawn in the enemies, but then prevent them from asking and all this kind of stuff. So now that we don't have any enemies, as the game continues, let's see, do these enemies eventually disappear? There they all go. So they're now disappearing as they go off the screen, which is the timer that we set before. It looks like it's quite a long timer, so I could set this maybe to 15 instead of 20 seconds. Let's just add the same logic for our enemy objects disappearing after time to our projectiles as well, so that they don't infinitely spawn and eventually clog up the CPU or the GPU or whatever. So the fire rate, where is it? Here it is. Here's the life timer. The life timer increases after a certain amount of time. We destroy ourselves. So let's just add that code to our projectiles as well. So there's that. There it is there. Now it's going to complain that life timer doesn't exist and lifetime doesn't exist. So let's copy those variables as well. So now our player projectile has them. And let's also do the same thing for our... We should really have called this one player projectile and enemy projectile, but... well, couldn't be bothered changing it now. So the projectile is the enemy version. So let's add those particular variables as well. And we'll add the same code for destroying ourselves. There we go. Now all we have to do is save. Because I've made multiple changes to different scripts, I'm going to instead hit Control-Shift-B. And that's sort of like saving all, but it's even better because it makes sure that there are no errors. And I can also do this with build solution, which you can see the shortcut here, Control-Shift-B. And that's just a good catch-all to make sure that all of your scripts are actually compiling and there are no errors in any of them in the solution, whether they're open or not in the Visual Studio IDE, it's called actually. So let's go ahead and set these values. So for example, our enemy projectile should probably last, you know, at least 5 seconds, right? So let's go ahead and set this time to 5. And then our player projectile is probably going to have to last the same amount of time. Let's set this to 5 as well. And now when we run the game and we look at these projectiles all coming out of our character in the scene, hopefully they will disappear after a certain amount of time. Look, there they all go. 5 seconds I think is about right. Or let's see, do these enemy projectiles disappear too early? I don't think they are. Even those ones that are shooting from very far away are disappearing only after they get off the screen. So perfect. And now look, we never have, as the game plays, we never have too many objects. Now, because our game is so simple, this maybe isn't a big deal. We could maybe have 100 of these projectiles, and even on a potato laptop, it might still run fine. But it's good practice because, you imagine if you were doing this and that each of those objects was doing a more complex calculation every frame. The game could just like die after playing it for 5 minutes because there's so many objects that are still moving off to the edge of the screen. So we've done a bit of housekeeping. We've cleaned up our game a little bit. I'm pretty happy with how things are going. Let's add some parallax scrolling, I should say. So the first thing I'm going to do is make something that can scroll, an image, a background. For this, I went ahead and created a new sprite. I can resize the sprite, so I can resize it to like 100 pixels by 100 pixels. So now it's a bit bigger. In fact, let's go ahead and make that even bigger. So I'm going to make it by 200 by 200. Ooh! So now I've got a big, massive old sprite. I think I was going to do sort of like the stars. So let's go ahead and make it black and then pick something for our light. Oops, let's make them single pixel stars. Maybe this is too many stars. One of the things you sometimes like to do is if something's pitch black, it can be a bit harsh on the eye. So I'm going to make it slightly more gray, a dark gray. So we've got this image. One of the things we can do is we can do that thing that I was showing you before, the tile mode. So I'm going to enable tile mode, and that way we can check to make sure that everything aligns so that this background can endlessly repeat. For example, I'm going to go ahead and make some sort of strange shapes in the sky, like just a big green line. And I can go ahead and make sure that it connects up by connecting up this line here with the line here that I start with. And I'm not really sure why there's a big green line in space. I tried to make it low contrast by making it very near the color of the background. But really I'm just using this to demonstrate how you can repeat a pattern. Maybe it's not space, maybe there's trees at the bottom of this, and you wanted to line up all the trees at the bottom or something, whatever the image is that you're making. So I'm going to go ahead and export this image as a sprite sheet, though it's only one image. So it's a sprite sheet of exactly one. And then in my downloads file folder, I have that new image, and I'm going to go ahead and drag and import that new image into Unity. All right, make sure compression, blah, 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 none, and no point, no filter. It's a sprite. Let's go ahead and create our new 2D object sprite and stick our sky in there. The scale is probably going to have to be pretty big because we want it to cover the entire screen. So I'm going to go back to my game view. I'm going to move this around until it's roughly in the center, and then I can keep increasing the scale. And I know I've been saying recently about 2D images and not using the scale, but keep in mind, guys, that this isn't a UI element, and that's why I'm increasing the scale. Whereas if it wasn't a UI element, if it was a UI element, rather, I would be wanting to use the rect transforms width and height. All right, I'm also going to set these to 0, 0, 0. So notice how, because we have our camera and it's an orthographic view, it doesn't actually matter how close or far from the camera this object is. Well, actually, once it goes past the camera stops rendering it. But it doesn't matter how far away this is because we've got an orthographic view. It doesn't change the scale, and that's different. Whereas if we set our camera to perspective, then the closer and farther our object, our sprite is, the smaller it becomes. Look at how it becomes bigger or smaller, because the perspective is determining the scale of our object. However, we're going to keep with this orthographic view, and I'm going to show you how to manually scale and move parallax. So we're essentially recreating the illusion of scale and distance, even though our camera view is orthographic. And then after this, I'll show you an easier way of doing something in perspective, Perspective is kind of easier, but a lot of the times for 2D games, you don't actually want to use perspective just because of the design philosophy, right? So here we've got our endless scrolling background, and I'm going to duplicate this and position it exactly where we need it to be. Presumably, if this is going to be zeroed out and our sprite is a certain scale, it should be easy enough to exactly work out where this other object should be to line it up. It looks like it's 12. 12 on the X value. Let's see, because if I do 13, what if I do like 12.1? You can see there's a tiny little gap. Now, I'm sure there's some reason it's 12. I could mathematically calculate from the size of my object at 200 pixels or whatever and scaling at 3, but or scaling it at 6. Oh, it's probably something to do with 6, because 6 is a modifier of 2, and then we've got 200. But whatever, I couldn't be bothered working out the maths. Anyway, we're just basically lining these up next to each other, so I can put this at 24. Not 14, 24. There we go. So we've got all of these, we've got these 3 versions of the background lined up. All right, so to create our sort of treadmill of stars, we're going to add a component to each of these objects. So I'm going to add component, and we're going to create a new script for our scrolling background. I had a previous attempt at this, and now I'm creating a new script. So scrolling background 2, I'll just call it. There's the end point that I got to with my experimentation. So I tried messing around with a whole bunch of maths, and then I gave up. So instead, we're going to try and simplify stuff by using lerping. And that way we don't really have to calculate all of the various distances and speed and divide it by blah, 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 and get very confused. Instead, what we can do is lerp, because essentially what we have is we have 2 values. The first value is where the object is, where it starts, and the second value is where it ends. So we kind of move it from the right to the left, and then we want it to loop back to the start again. So what we can do is we can lerp between these 2 values. In this case, we're sort of just using a timer, but instead of just moving during the timer, we're going to use a vector3 lerp. So what do I mean? So what I can do is I can go to my transform.position in our scrolling background and set it equal to vector3 dot lerp. Now this lerp is going to go ahead and ask for 3 different values. It's going to ask for our vector3a, our vector3b, and our float t. And what this means is it's like the first value is the start point, the second value is the end point, and the third value is the value that will determine where along the spectrum between these 2 values we are, where 0 is the start point and 1 is the second point. So 0.5 is like halfway between, and so on. So what we can do is we can go ahead and create a new vector3 for our start. So this will be like our start point. A vector3 for our endpoint. And then for the last value, we're going to use our timer, which will increase. So I'm going to go public float, move timer. So that way we can go ahead and use our start point here for where we're coming from. Our endpoint is where this scrolling will go to. And then our move timer is going to be our value from 0 to 1. And we'll set that. So we're going to set our position from 0 to 1. And that way, if we go ahead and add plus, we want to do this in our update as well. If we add plus equals time to our move timer, time.delta time, then our timer will keep going up. If our timer is greater than 1, and we can hard code this to be 1 because remember this value should be from 0 to 1 for our lerp. Then if it's greater than 1, we're going to set it to 0. Now we could set it to 0. The only thing is that this isn't going to be completely smooth. One sort of like little trick is to make this smooth. For example, if move timer is let's say it's 1.001. If we jump to 0, we're actually losing that little 001. That 0.001 or something like, there's a little value there. So, it's not quite reflecting the value in our time.delta time. What we can actually do is instead of setting it to 0, we can set it as equal to minus equals 1. So if it's greater than 1, we take 1 away, which will leave the remainder extra time, which will give us a completely smooth motion. Okay. So we've got our value. It's going to go all the way up to 1 from 0. Then it's going to be reset to 0 again. Let's go ahead and multiply how fast this happens by speed. We'll just create a quick float multiplier, and then we can control how fast our scrolling happens with this speed variable. And really, that's all we need to do. We just have to set up all our variables. So let's practice. Let's just try this with one of our values, so one of our objects. So I'm going to turn these all off. So I've just got this one version of our scrolling. We're going to set the start point at 0, 0, 0. The end point we'll set to, let's say, -12 on the x-axis, and then our speed we'll set at 1. So every second, this is going to move from this start point to our end point, and it's just going to loop over and over again. And by using this lerp that we're looping between our objects, we don't have to worry about calculating how fast it needs to go to keep looping, because we're just using the math .lerp. Now, whenever we turn on these other objects, what we want to do is have them looping across the same values of the start point and the end point, but we can set the start timer value to be different so that they're staggered, so they're offset, so that they'll loop, but they'll loop staggered from each other. So that means the move timer of this object here this can be 0. It's about to flick from the left to the right. However, this one should be at move timer 0.3 repeating, because it's, you know, a third of the way. It's almost there. And then this one on the right we can stick at 0.666 repeating. Then we need to work out what our values are from our jump. So our jump position here can be 0 to start with. Actually, let's make it 12 to start with, and then whenever we jump, we'll jump to -24, because there's a difference of 12 between each of these values, and we want to multiply the difference between these all should be 12 multiplied by 3. So we'll have -24 on the x-axis, and we'll start at +x, and we'll see how that goes. So let's copy these values across. So I'm going to select them all, and you can see these little dashes when I select all of these objects in the inspector shows that they have different values. So I'm going to set this to 12 and the endpoint to -24. So now whenever I run the game for each of these different objects, we've got some very strange behavior. Not what I was expecting at all. It almost looks right. I think it's because we've inverted our values. We're starting at 12 and we're going to -24. Hang on. Let's turn these objects off. Let's run it and see what's going on. Oh, I think it's just that we haven't set the speed. The speed of these is 0. Whoops. We've got to set the same speed for all of them. In this case, let's set the speed to 1. See what happens. So now our infinitely repeating pattern, it looks like the whole thing is jumping backwards, but actually if I go through it by frame, you can see once it gets to a certain extent, this object here is going to jump to the front of the queue, and so on. Because they're at different staggered timers, they'll jump at different points. Because there's 3 of them, that's why we've got our 0.3 and 0.66 on the timer. So we've created our infinitely scrolling object. One thing I've noticed is the explosion is actually hiding behind them. We want this to be even farther back than an explosion, so I'm going to say order in layer is -2. And that way our explosions will happen in front of our endlessly scrolling space. Now this looks like that we're going really, really fast because space and all the stars are moving very, very quickly. We could go ahead and set our speed to something like really slow. Oops. 0.0001. And now the scrolling, okay, that was too slow. Let's bring it up. There we go. And now it looks like we're floating in space and the stars are moving very slowly behind us. So I'm going to go ahead and do that and set it to something like this, 0.001, because now we're going to do some parallax stuff. And parallax is essentially just where we have different objects in the background that are moving at different speeds relative to the player. And because they move at different speeds, it looks like they're at different distances. Because the farther something away is, the less it will seem to move as you move relative to it. So I'm going to go ahead and duplicate these objects that I have for our moving background. I'm very lazy here. I'll make a quick sprite. So the same thing that we used to make our space sprite, I'm going to go ahead and select all this stuff and delete it. We'll make it the same size because that's how lazy we are, so we can use the same implementation. And what would we have in space? Maybe like an asteroid? Here's a big old asteroid. Hello! There must be a gap in here somewhere. Oh, there it is there. So let's make a big old asteroid. We can have like different parts of it. This is sort of like a cow asteroid. Boop, boop, boop. I don't know. Doesn't really look like an asteroid. Who cares? I'm going to go ahead and save this out. No, not as a pixel. Export as a sprite. There we go. We're going to drag that sprite in. Let's go ahead and set this to none. Oh wait, that's the wrong sprite. Where's our new one? Here it is here. I should probably rename them if I was being fastidious. Instead, let's select one of these new sprites. Let's turn them into a asteroid. There it is there. And actually, we don't actually need these other two because we're just using this asteroid one. And now, if I just go ahead and run the game with these same values on the asteroid will move at exactly the same speed as our endlessly repeating background. But if I just go ahead and change the speed, so I make it 10 times as fast, 0.1 speed, we can see that because our asteroid is moving at a much faster rate, and it is just going to use the same code, so it's just going to replicate. It's just going to replicate and repeat. Maybe we don't want that, but you know, for now that's what our code is. But our asteroid is moving and repeating at a much slower, at a much faster rate than our background, which means that it looks like we're closer to the asteroid than we are to the space background. And so we can create this parallax element. I'm just going to go ahead and duplicate this asteroid. I could move it like down here. I have to be careful though that I set the values because it's over on the far right. I probably want to set the values similar here, so my 0.66, so that it starts off in the right place of the lerp. So now we've got these two asteroids that are duplicating, and you can see, look, it doesn't matter that I changed the y-axis because our lerp is overriding those values. So to get by that, what we can actually do is create an empty for our sprite, remove the object of the sprite from the parent and stick it on the child instead. And because this child is never going to be affected by the coding, except that the parent is the thing that's getting moved, what I can go ahead and do is actually let's put this view back to 2D. Is oops, not scrolling background, a sprite. Thank you very much. Sprite render with this asteroid. So now we can include the offset just as simply. Let's like reset this at 0. We can include the offset in the child, and because the offset's in the child, transform relative to the parent, and the parent is the thing that's getting set by our code, the offset will be retained even though the code is setting the asteroid value to be exactly 0 on the y-axis. So now we've got these two endlessly repeating asteroids that look like they're closer to the player than the background. The background is almost moving so slowly as it almost looks like it's not moving at all. And you could do like a really strange effect here, couldn't we, where we make the background of the stars move really fast and the asteroid's slow. So it's almost like we're going through we're like warping through space, and somehow these asteroids are part of that. I don't know. It doesn't quite look right. But anyway, I think you get the point. We can set our values at different speeds to manually implement parallax scrolling.